Set up the definite integral required to find the area of the region between the graph of boom and boom. Right, you see the answer there. How did they do it? Well, step number one is find where the graphs intersect. Where do those graphs intersect? So to do that, you set one of them equal to the other. That's where they intersect. When they're equal, they have the same height. When this y value equals that y value, set them equal and solve. Now, how do we solve an x squared equation? We step one, get 0 on one side. So I'm just gonna bump both these guys over here. Boom, and I'll bump him right there. So that's 0. When the minus x squared jumps to the other side, becomes plus, right? Things change. I'm moving it that way because I want that positive. You don't have to. Minus 2x, he just comes straight down. Minus 23 comes straight down. And then this positive 12 jumps to the other side, becomes a minus 12. Combine those. What is that? Minus 35, right? So there we go. Step two, you can factor, which is going to be the quickest way with the two parentheses equal to 0. So I'm just going to do that. That's quicker. So this is x times x. What are two numbers that multiply to be 35? 5 times 7. And that can add to be negative 2. Well, notice I put the 5 and the 7 in first, no signs. How do the signs go? The sign in the middle always goes to the bigger number. 7 is bigger than 5. The other one can be plus or minus. Which way does it need to be? It needs to be plus. How do I know? Because minus 7 plus 5 makes minus 2, adds to be minus 2. And they multiply positive times negative to be negative 35. So that's our pair. Now, if you're rusty on factoring, no problem. I'll say, or you could just do the quadratic formula, right? Remember that? Negative b plus or minus the square root of b squared minus 4ac all over 2a, right? You could do that, but I'm just going to finish up. So we're not done here. You have to set each one equal to 0 separately. Remember that? That's just logically true because these are timesing to equal 0. If I told you, hey, I'm thinking of two numbers and they multiply to be 0, the first one could be 0 or the second one could be 0. That's just logical. Jump this to the other side, it changes sign. Positive 5 becomes negative 5. Jump to negative 7 to the other side, it changes, becomes positive 7. If you did the quadratic formula, you get the same two answers. Your A would be 1. This would be your B, negative 2, and your C would be negative 35. You plug them into the quad, you get the same two answers. I'm not going to show all that. I've shown it on lots of other videos. So negative 5, positive 7, there's our two x values. That's where they intersect. That's where they intersect. So now, step number 2, we're going to um, find which function is on the top or the bottom between, in the middle of the x values. So between negative 5 and positive 7. So let's do a little number line here. So we got, say, negative 5 over here. Positive 7, 0 would be about right there, just for perspective. Okay, so we know, because we know they intersect at negative 5. So which function's on the top or the bottom? Well, let's, to figure that out, plug in an x value in the middle, plug in x value in the middle to both equations. So I go back up, grab both equations. So here's the first one, 12 minus x squared. So I'm going to go, okay. And the other equation, which is right here, minus 2x minus 23. I'm going to plug in, x equals 0 because that's in the middle. Now, it doesn't have to be, you could have done negative 1 or negative 2 or negative 3 or negative 4 or 1, 2, 3, 4, 5, 6, any of those, anything between negative 5 and 7. So I'm just going to plug in x is 0 and see what we get here. Oops, back here. So here we go. Plug in. So I'm going to plug in right there. A 0? What do I get? So I get, that's easy math. Y is 12. I'm going to, oh, better use the right color here. So this one I'm going to plug in 0 right there. And I'm going to, it's again easy math. Y is minus 23. So this one's on the top because 12 is bigger than negative 23. Remember, the y value is where it's at. So at x equals 0, this one is way up here, and this one is way down here on the bottom, right? So this function's on the top. Now, what is that? That's a parabola, right? You got x squared, which is always a u shape. It's a negative x squared, so it's a u shape upside down. So that one looks like something like that. Oops, you do that with the drawing tool. Well, good enough. Okay. And it's upside down U shape. Okay. Now the other one right here, this one's a line and it's on the bottom. So it's a straight line on the bottom. So, oh, but I didn't do that very well, did I? It's a line going down. Yeah. Okay, let me do a better job here. I know a little bit more of the story now. I'll do the line first. The line's easier place to start. So I'm going to start with the line. So I'm going to say the line goes, I don't know what exactly it looks like, but just to make life easy here, like that. So line going down, how do I know that? Look, it's got a negative slope right here, negative 2x, negative slope. So let's do that. And then I know right at this point and right at this point, they intersect, right? So I'll take the other one now, and it's a parabola. Okay, going like this. Well, it didn't work at all, did it? All right, I'm just going to freehand it. It's going to look terrible, but here we go. Oh, I didn't freehand it. I forgot I was on the same thing here. Let's try that again. All right, one more time. This is it. Okay, good enough. Looks terrible, but hey, they have to intersect. My point is they intersect at -5 and +7. We found that out earlier, right? We found out that's the points of intersection. So the line's on the bottom and the parabola's on the top. And we want to find this area in between them. So how are we going to do that? Well, we're going to fill it up with rectangles. All right? We're going to add up the area of a bunch of rectangles in really an infinite number of rectangles. So it's going to be the integral from the left to the right, right? And so for each of these rectangles, let me just pick one out here, like this one right here. What's the area of that rectangle? Well, dx is its width. That's how wide it is. And by the way, we know this is dx. They told us dx. So we're doing sideways rectangles. Dx is its width. What is its height? How high is it from, use a different color there, from there to there? Well, it's going to be the top minus the bottom. Top minus the bottom. That's the height. That's how high that is. So that rectangle is just length times width or height times width. So the area of that rectangle, of any of these rectangles, is the width, dx, times the height, which is top minus bottom. So that's what we're going to do. We're going to say the height here times the width. And the height is top minus bottom. And what is the top? It's this function. 12 minus x squared minus, and what's the bottom? It's this function, minus 2x minus 23. Top minus bottom times dx, because dx is the width. So there it is. So it's the integral from left to right. And what is left and right? This is left, -5. This is right, +7. So -5 to +7. I'll simplify this. 12 minus x squared. Distribute. That'll be plus 2x plus 23 dx. Last step, -5, +7. 12 and 23, what is that? 35 minus x squared plus 2x. You can put those in any order, doesn't matter. There we go. That's the integral that'll find there. Let's see, it's right. -5 to 7, Right, negative 5 to 7. Minus x squared plus 2x plus 35. Minus x squared plus 2x plus 35. There it is. There's that integral. And we're not going to compute it. I know you can do that. We did that in earlier sections. We just don't want to make this too long. So we're just going to stop at the setup. If you cranked out that integral, did anti, and plug in the bounds, all that, you'd get the exact area between these graphs because you're adding up a bunch of rectangles, right? Now, let's look at the real picture just to see what it looks like. So there's the real picture on Desmos graph here. So there's the parabola. See the parabola's on the top, the line's on the bottom. I had it up here. It's down here, actually. Good enough. And there's the integral to find the area between them right there. And so that's how we do it. And there's the integral to do it. And there we go.